Okay, so first thing we need to do here is differentiate our curve. Since obviously we've got lots of x's and y's in there, we're going to use implicit differentiation. So differentiating 2x is going to become 2 minus, and then we get 8y dy by dx plus, now this one is a product rule, so differentiate with this, so differentiate and times by this, and then differentiate and times by this. So we're looking at 6xy plus 3x squared dy by dx. And then on the other side of the equals, I've got 8x. Now I want everything with a dy by dx on one side, so let's keep these here. 3x squared dy by dx minus 8y dy by dx, and then everything else I'm going to take to the other side. So we already have 8x there, minus 6xy minus 2. Factorize out my dy by dx. That gives me 3x squared minus 8y inside the brackets. And then I want to divide by that bracket. So dy by dx equals... Now, I want to find the gradient at point P. And P says that x is 3 and y is 2. So that's why I want to substitute into my dy by dx. So I'll do this bit in black. So now we've got 8 lots of 3 minus 6 lots of 3 lots of 2 minus 2 along the top. And then we got 3 lots of 3 squared minus 8 lots of 2 along the bottom. And now we need to go to my calculator. And we get minus 14 over 11. Now, we actually want the equation of the normal. So our gradient will be, flip our 14 over 11 to 11 over 14 and change the sign. So we want this gradient at the point 3, 2. So as always, let's use y minus y1 equals mx minus x1. Substituting in my values. And then I want to multiply by that 14. So we get 14y minus 28 equals 11x minus 3. Now obviously I actually normally like to skip this particular line, and I would normally jump straight to this next line because I would expand the brackets in the same go as multiplying by the 14. Just taking the extra steps for you guys here. Now we want it in the form ax plus by plus c. So the 11x is positive, so let's get everything to the right. There we are. So obviously taking away the 14y and adding the 28 there leaves me with 11x minus 14y minus 5. Okay, so looking at this one, we have a differential equation and we need to essentially integrate. Notice that we've got y's and x's. So what we need to do is take this and these and get everything with a y on one side, everything with an x on the other side. Now, the dy's on the top, so we want the y's on the left, and we want to take the dx to the top, so we want the x's on the right. So that would mean I get 1 over 4y squared dy on the left, 1 over root 4x plus 5 dx on the left. And then I am integrating these. So on the left, I'm going to take a quarter outside, and I'm integrating y to the minus 2. On the right, I am integrating 4x plus 5 to the power negative a half. Now, actually, after looking at this, I can see that I'm going to end up with a factor of 4 coming out of here divided by, so actually I'm going to multiply by 4. So what I'm actually going to do is I'm going to integrate this instead. Okay, and it's just to make my life a little bit easier. It shouldn't make a difference when I do integrate. If I'd done it from the previous step, it'll just make my life a little bit easier in this case. Now, integrating my y to the -2, add 1 to my power, divide by my new power. My second part now, so I'm going to add 1 to the power, so it's going to become a half, divide by the new power. Then I also need to divide by this differentiated. So this differentiates to 4, I need to divide by 4, which is multiplying by a quarter. And then of course I got my plus c. Now you can see why I put the 4 over there, because these 4's will cancel nicely, just making my life a little bit easier. So I've got -1 over y on the left, and now because I'm dividing by a half, it's times it by 2, so 2 4x plus 5 to the power of half plus c on the right. Now I need to rearrange to make this y equals. So this is going to be y equals minus 1 over 2 root 4x plus 5 and then don't forget the plus c is also on the bottom, so I could put it this side or I could have put it the other side. I think I prefer it written this way around a little bit. It's a little bit clearer that it's outside of the root there. Now, the question gives me my values of x and y. X is minus a quarter, y equals 1/3, and this is what I need to find my value of c. So I'm going to use the set just from a little bit before we got to this point, just because I think it's a little bit easier to substitute into. So we got y is 1/3, so I got minus 1 over 1/3, which will be nice in a bit. 2 lots of, now I got 4 times negative a quarter plus 5 and plus c. So on the left I've got -3. On the right now I've got 4 times minus a quarter is -1 plus 5. That's obviously going to be 4 there, which is nice. So we got -3 times 2 lots of the square root of 4 is 2 plus c. So we got c is equal to -7. Now, substituting back into my original, I've got this -7 plus 2 root 4x plus 5 on the bottom. Alternatively, this could now be written as 1 over 7 minus 2 root 4x plus 5. So here we have an improper fraction, and they've given us the form to make our life a little bit easier, as this is often where people forget when they're dealing with an improper fraction. So that's nice and straightforward. So let's have a look. So my g of x, if I'm just going to do the right hand side first of all, this is going to be equivalent to ax over that x plus 3, and times on the top by x plus 3 would give me ax squared x plus 3. Now we've got b x plus 3 over x plus 3 plus c x plus 3 over x plus 3 plus d x over x plus 3. So getting all four of these terms over x times x plus 3 is what we need to do, so that then we can compare the top lines. So essentially what I've got is 3x cubed plus 8x squared minus 3x minus 6 is equivalent to ax squared x plus 3 plus bx x plus 3 plus cx plus 3 plus dx. And I'm using up a lot of room here. Now what I'm going to do is I'm going to first look at the coefficients of x cubed. So on the left that just leaves me with 3, and on the right the only way to make x cubed is ax squared times x, which is ax cubed, so just a. And that's my first one. Now I'm gonna substitute in x equals 0, as that will give me a letter for c. So let's do that. That'll give me, on the left side I've got 0, 0, 0, just minus 6. On the right it's going to be 0, 0, this is 0, so I've just got 3c. So c is got to be negative 2. So that's two nice and easy ones found straight away. Now I could find d if I let x equal negative 3. That'll help me out there. So on the left there's a little bit more to do. So 3 lots of minus 3 cubed plus 8 lots of minus 3 squared minus 3 lots of minus 3 minus 6, and that equals minus 3d. That gives me minus 6 on the left is equal to minus 3d, so d is equal to 2. And now I've got a, c and d done. Now all I've got left is to find b. Easiest to find b is looking at the coefficients of x squared. So on the left I've just got 8 in front of the x squared. Now on the right I got ax squared times 3, so that's 3a x squared, and I've got bx times x, that would be bx squared, and then those are the only two ways of making x squared on the right hand side. Now we already know what a is, as a is 3, that'll give me 9 plus b, so b needs to be negative 1. Now I've got all four of my values, I can now state what g of x is equivalent to. And here we have it. So g of x is equivalent to 3x minus 1 minus 2 over x plus 2 over x plus 3. And that is part A done. So part B wants me to differentiate. The first thing I want to do is sort this out. So 2x to the minus 1 plus 3, x plus 3 to the minus 1. Now let's differentiate. 3x will differentiate to 3, minus 1 will disappear. Minus 2x to the minus 1, so multiply by the power, becomes plus 2x. Taking one away from the power is minus 2. Next bit, multiply by the power, so minus 3x plus 3. Take one away from the power. We'd also multiply by the inside differentiated, but since that's 1, it doesn't change it. So just rewriting this in a similar form to the question will give me this. But as I've said numerous times before, leaving it like that is perfectly acceptable. Now, part C says explain why that differential of g of x is greater than 3 for all values of x in the domain of g of x. So the first thing that we can say is that, you know, you've got x squared and you've got this bracket with x in it squared. So these values are always going to be positive. Okay, so let's just have a look now. So as x is tending towards infinity, x squared is tending towards infinity, and that x plus 3 also tends towards infinity. What that means is that 2 over x squared would actually be tending towards 0. 3 over x plus 3 squared tends towards 0. I could actually take these bits out. These bits aren't actually necessary, so let's do that to simplify it a little bit for you guys. Now, as x tends towards negative infinity, this scenario still happens, so it doesn't really matter. I can put it in the same thing for both. That means that as x is tending towards infinity plus or minus infinity, g of x is tending towards 3. Okay? Because what you're saying is, you're basically saying that this is heading towards 0, this is heading towards 0, so I'm left with 3. Okay? Now, I think that would probably be enough, but you could also make the statement that as these are heading towards infinity, this one is going to be larger than this one. Just because of that, essentially that plus 3 on the bottom means that bottom's going to be bigger, so like by quite a bit. So as they go towards plus or minus infinity, this is going to be greater than this. So that's another little extra bit you could add in, but I think this should be enough. And actually, looking back in the question, the fact that x is greater than 0 actually means that I can get rid of this bit. So I can actually forget about this one. So actually I can get rid of that. That's not a problem. Okay, and just keep it as x tending towards infinity there. Okay, so just that bit of information at the bottom. So first let's think about writing our f of x as 1 minus 4x squared to the power a half, and since we have a 1, it should be nice and easy, the expansion. So we're going to get 1 plus a half minus 4x squared plus, now we've got a half minus 1 minus 4x squared squared, and that's over 2 factorial. And we want one more term, so we got a half minus 1, a half minus 2, minus 4x squared cubed over 3 factorial. So that gives me 1 plus, sorry, that'll actually be 1 minus 2x squared. Then we have a half times negative a half is negative a quarter. That's times negative 4 but squared, so that's times by 16. So we've got minus a quarter times by positive 16. So it's going to be minus 4x to the power 4, but that's going to be over 2. I'll deal with that in a second. Now we've got half times minus a half times minus 3 over 2. And that's 3 over 8. Minus 4 cubed is minus 64. So 3 over 8 times minus 64 will be minus 24 x to the power 6 over 3 factorial is 3 times 2 times 1. So finally I get 1 minus 2x squared minus 2x to the power 4 minus 4x to the power 6. Now for part B we need to use x equals a quarter on this to get something for root 3. So first let's put x equals a quarter into my square root of 1 minus 4x squared, and this is going to give me the square root of 3 quarters here, which I can write as square root of 3 over 2. And I obviously want the square root of 3, so if I substitute x equals a quarter into my expansion of this, or here it is here, then this is going to be equivalent to root 3 over 2. So once I've done that, what I need to do is multiply by 2 to get that equivalent answer. So think of it like this. If I put 1 minus 4x squared up here, is 1 minus 2x squared minus 2x to the power 4 minus 4x to the power 6. Substituting x equals a quarter in, we know that this left hand side is root 3 over 2, and then on my right hand side I'd have 1 minus 2 lots of a quarter squared minus 2 lots of a quarter to the power 4 minus 4 lots of a quarter to the power 6. So that is 1 minus 1/8 minus 1 over 128 minus 1 over 1024. And that is of course root 3 over 2. I want root 3, so I'm going to multiply them all by 2. So 2 minus a quarter minus 1 over 64 minus 1 over 512. And that gives me 887 over 512, or to 4 decimal places as the question was asking is 1.7324. And if you just double check what root 3 actually is in your calculator, you can see it's 1.7321. So very, very close. So we need to use parametric differentiation to find the gradient. So if I think of my x equals, that's 5 plus 2 tan t. And differentiating this is dx by dt. The 5 is going to go, and tan differentiates to sec squared. Then looking at my other one, I've got y equals 8 sec squared t, and think of it like this. So we get dy by dt is multiplied by 2, so 16 sec t, and then sec differentiates to sec tan. So we get 16 tan t sec t squared. And dy by dx is equal to dy by dt times dt by dx. So 16 tan t sec squared t times 1 over 2 sec squared t. Now you can see the sec squareds are going to cancel with each other. The 2 is going to go with that 16 to leave me with 8. So this leaves me with 8 tan t. Now we need to find the value of t, but we know the value of x. So when x is 3, we get 5 plus 2 tan t from this equation here. So that means that 2 tan t is going to be equal to negative 2. Tan t is equal to negative 1. And that means that t is negative 45 degrees or negative pi by 4. Obviously we should be dealing in only radians here, not dealing with degrees, but I do like to look at degrees, I use them a lot. And just double checking the range up here, this is my value that is within the range. The values that work either side of this will fall outside of my range. So I am using this t equals minus pi by 4, and I'm substituting it into my dy by dx. So dy by dx is 8 tan minus pi by 4, or I can actually see it straight from this part here. Tan t is negative 1. I could just substitute this straight into here. 8 times negative 1. It doesn't really matter. But yeah, my gradient is going to be negative 8. And that's part A done. Now, part B is about finding f of x. So we're actually finding y equals f of x. So that means I need to combine these two together. So what I want to do is I want to make this one here tan equals, and I know the sec squared I can change into a form with tan squared. So this is the equation. We'll work on this y one first. So y equals 8 times tan squared t plus 1, or 8 tan squared t plus 1. Sorry, plus 8. Almost made a very silly mistake there. Then from the x, we have x minus 5 equals 2 tan t. Divided by 2, I get x minus 5 over 2 equals tan t. And then that is what I want to substitute into my y. So that leaves me with y equals 8. X minus 5 over 2 squared plus 8. Now this is the same as 8x minus 5 squared over 4 plus 8, and I can see that 4 will simplify with this 8 or cancel with my 8. So this leaves me with 2x minus 5 squared plus 8, and that is my y equals f of x for part B. Now part C, I actually fit this in over here. Part C happens, it's the range. We can see that this part here, because it's squared, is always going to be positive. And 2 times a positive number is always going to be positive, and it's going to be large. Okay, so as it increases, it's always going to be above this 8. So this 8 is the smallest possible value for y, and this will happen when x equals 5. So my range is greater than or equal to 8. Okay, sometimes you can see it written as f of x is greater than or equal to 8. Okay, and that is obviously for the range of t between minus a third pi and a quarter pi. Very strange that it's 2 marks where it's such an easy question, but maybe it would have been nice to have an extra mark for B and just a 1 mark for C. But hey ho, that's the way it's done. Nice and easy though. Unless I guess they're allowing one mark for follow through with a mistake on B, I'm not sure. So we're going to integrate but with a substitution. So we know that u equals 3 plus 4 sine x. Du by dx is going to be, well, 3 is going to disappear and sine is going to differentiate to cos. So du equals 4 cos x dx. Now also let's look at that top part here. So we've got that 16 sine 2x, and sine 2x is 2 sine x cos x. So we're left with 32 sine x cos x. So this is what I'm integrating, and what I'm going to do is I'm just going to change the top into this form, and obviously this bottom bit will become u, and then this bit is going to come into play once I've changed this top bit. Now then, what I can see is that now I can replace this 4 cos x dx. So if I got the dx there, the cos x there, and take a factor of 4 out of here, what that will do then is leave me with just 8 sine x on the top. Now I'll take a few extra steps just to make this clear. I'll leave the limits off for a bit to save a bit of time, but essentially this is what I'm doing. 8 sine x multiplied by 4 cos x dx. And then on the bottom we know that's just u squared. Does that make sense? So 4 times 8 is my 32 sine x cos x, and the dx. Now the 4 cos x dx is here, is du. So now what we've got is 8 sine x, and that's a du over u squared. Now obviously we need to sort out this sine x, and we can get that from this here. So I'll do this in black just on the side underneath so you can see, but if I start off with rearranging it, so take away the 3, I get 4 sine x. So that would mean that 8 sine x is going to be 2u minus 6. Okay, or it could be written as 2u minus 3. Doesn't really matter there. Okay, so that is what I'm going to be substituting in to my integral. So now my integral is 2u minus 6 over u squared du. So we're pretty much ready to go. There's one more step that we need to sort out, and that's my limits. So my limits here, pi by 2 and pi by 6, they are limits in terms of x. I need them in terms of u. Okay, so I'm just going to give myself a bit more room and then I'll show you that one. There we are, a bit more room. So when x equals pi by 2, u equals 3 plus 4 sine pi by 2. Sine pi by 2 is 1, so we got 3 plus 4, so u is 7. So that means the pi by 2, which is the top limit, has been replaced by 7. U equals 3 plus 4 sine pi by 6. Now sine of pi by 6 is a half. 4 times a half is 2. So we get 3 plus 2, so u is 5. So my bottom limit now is 5. So this is now my new integral, what I'm trying to do. So I basically have changed everything from x's to u's. So for this to work, you need it all in u's instead of x's. You need a du, and you need your limits in terms of u as well. Now it should be a straightforward integration. So let's go. 7 over 5 2u over u squared minus 6 over u squared du. So I'm actually integrating 2 over u minus 6u to the minus 2 du. So that gives me 2 ln u minus, so add 1 to the power will be minus 1. So we get 6u to the minus 1 over minus 1 between 7 and 5. Or 2 ln u plus 6 over u between 7 and 5. And substituting in, we get 2 ln 7 plus 6 over 7 minus 2 ln 5 plus 6 over 5. Now we've got a little bit of sorting out to do. So my 2 ln 7 we're going to write as ln 7 squared plus 6 over 7 minus ln 5 squared minus 6 over 5. And then we can see that we've got ln 49 minus ln 25, and then minus 12 over 35. With logs, if I'm taking them away, it's the same as dividing the numbers. So we've got log 49 over 25 here, minus 12 over 35. And there we have it. If we just double check the question, A and B are rational constants. That means they are fractions, okay, not integers, so we are perfectly correct. Now, what I would also suggest is that you can put these values or the original one into the calculator and check that it gives you the same numerical answer. And I just did it, and it does. It gives me that 0.330087 and so on, which is exactly the same numerical answer as this. And when I say checked it, I checked it with this value. Using in your scientific calculator, you do have the numerical ability to get a numerical answer for the integration. So I just stuck this in with these two limits. Okay, it's always worth doing that just to check your answer during the test or exam. Okay, question 7. Not the easiest one. What we really need to do is we need to think about perpendicular lines here. Closest point is going to be perpendicular to that point. And first we need to think of that as a vector. So if I think of the line AX, this, if it multiplies by the direction of r, so minus 4, minus 3, 5, should be perpendicular, so it should equal 0. Now what we've got to do is we've got to find out what AX is. So AX would be A to the origin plus origin to X. Now AO is the same as minus OA, or OX take away OA. Now OA, I know, is the position vector 9, minus 3, 2. And OX is going to be the position vector or the point on L, on line L. So that's going to be 4 minus 4 lambda, 2 minus 3 lambda, minus 3 plus 5 lambda. So we've got OX is 4 minus 4 lambda, 2 minus 3 lambda, and minus 3 plus 5 lambda. And we're going to be taking away 9, minus 3, and 2. So that's going to give me minus 5 minus 4 lambda we're going to get 5 minus 3 lambda and minus 5 plus 5 lambda. And that is my AX. So this is what we've got. Now, what that means is we've got minus 4 times minus 5 minus 4 lambda, minus 3 times 5 minus 3 lambda, and 5 times minus 5 plus 5 lambda, and this is equal to 0. So expanding, I get 20 plus 16 lambda, minus 15 plus 9 lambda, minus 25 plus 25 lambda equals 0. This will give me 50 lambda minus 20 equals 0. 50 lambda equals 20, lambda equals 2/5. That means the position vector OX, or the coordinate of X, is going to be 4 minus 4 lots of that 2/5, 2 minus 3 lots of 2/5, or minus 3 plus 5 lots of 2/5 there. And that is obviously just straight in R. So this gives me, and I'm going to put this one in decimals. I don't normally, but it just seems to be a little bit easier in this case. So that is the coordinates of X. I now need to find the distance, shortest distance. So AX is just going to be AX. We know the perpendicular. So I know it's AX. This would equal the square root. I'm just going to leave it as a square for the second. So we got 9 minus 2.4 squared. It's just the difference between my coordinates of A and my coordinates of X. Plus minus 3 minus 0.8 squared plus 2 minus minus 1 squared. This is going to give me 67. That means this distance, AX, is going to be root 67. Now, I could have just written in straight in terms of AX here and put the square root over it and the square root there. Okay, whatever you prefer. Now, part B. So, I think there's more than one way of doing this. If I'm thinking about it, I've got a line, I've got A, say here, we'd found X, which is obviously perpendicular because that's the closest, and then if it's a reflection we need to keep on going, and there would be B. So what I'm going to do is I'm just very simply going to look at the X, the Y and the Z individually. How do I get from A to X and then do the same to B? How do I get in terms of Y from A to X and then from Y to B? How do I get in terms of Z from A to X and then the same from X to B? And I think that's the easiest way of doing it. So I'm essentially thinking of going from A to X to B. And if I think of my A's, let's go 9 minus 3, 2. And my X's are 2.4, 0.8 and minus 1. And obviously the B's I need to find. So let's have a look. How do I get from A to X? So I need to subtract 6.6. So I'm going to do the same here. I'm just going to take away 6.6. And that's going to give me negative 4.2. Now I'm going to do the same with my Y values. So how do I get from minus 3 to 0.8? Well, I need to add 3.8. So I'm going to add 3.8 to my 0.8, and that's going to give me 4.6. And then finally, how do I get from 2 to negative 1? Well, I'm going to take away 3, So I'm going to do the same here. I'm going to take away 3, and that's going to give me negative 4. So my coordinates of B are minus 4.2, 4.6, and minus 4. And if you check that distance, XA, you should find, XB, you'll find that it is the same distance as AX, the root 67. I have double checked it already. Okay, hopefully that's okay. Like I said, quite a difficult one, this one. Let me know in the comments how it was for you, or whether you'd already managed to solve it a different way. Please let me know. I'm always curious to find other methods. So this one is integration by parts. Since there is an ln x in here, we need to make that one the u. So u equals ln x, and dv by dx is going to be equal to x squared. Du by dx, 1 over x, and v x cubed over 3. Now for this I like to put an I equals up here, so that then I can carry on with just the I equals down the bottom. And this is u times v, so that is x cubed over 3 ln x minus, and it's v times du by dx, so x cubed over 3 times 1 over x dx. This will cancel with this one, and then we can go for it. So x cubed over 3 ln x minus, and we are actually going to integrate x squared over 3. So let's do that. X cubed over 3 ln x minus, and then integrating this, we get x cubed over 3, so it's going to become over 9 plus c. Now for part B, we are integrating, but it's going to be a volume, and the volume is pi integral of y squared dx between a b and an a. So in our case, we are integrating between e, and to find the other limit, which is this point here, I need to consider when y equals 0. So when y is 0, x ln x equals 0. So that means x equals 0 or ln x equals 0. Well, x equals 0 is obviously this point, so we do want this one. And this happens when x equals 1. And you can rearrange your logs to get that if you weren't sure about it. So that is then my bottom limit. Y squared, so that's going to be this x ln x squared dx. So I am looking at the integral between e and 1 of x squared ln x squared dx. And I'm going to approach this very much like I did the previous part. So I'm going to make u equal to my ln x squared, and dv by dx equal to the x squared. So du by dx is going to be 2 ln x multiplied by the inside of the bracket differentiated. So we get 2 over x ln x, and v is going to be x cubed over 3. And like a lot of these, I make sure I'm going to put that I in there before I proceed. Now we can say I equals, and then it's u times v, so x cubed over 3 times ln x squared minus the integral of, and then it's v du by dx. So that is x cubed over 3 times 2 over x ln x dx. And of course all of this, don't forget, is multiplied by pi. we mustn't forget that pi, and we mustn't forget the limits are between e and 1 on all of this. Okay, so I'm just actually going to put curved brackets in at the moment. Now let's get rid of that x with one of those, and we can see that we've got essentially 2 over 3 x squared ln x, which is very similar to what we had in part A. So I'm just going to rewrite this a little bit nicer. X cubed over 3 ln x squared minus, between e and 1, we've got 2 over 3 x squared ln x dx, and of course all of this is multiplied by pi, and obviously it's between the limits of e and 1. So now you can see that this part here is the same as this, what we did in the first part. The only difference is that 2/3, which I can take outside. So we can use our answer now to part A to help us with part B. So this is now I'm going to use my square brackets so I can put my actual limits in. So we've got x cubed over 3 ln x squared minus 2/3 of x cubed over 3 ln x minus x cubed over 9, and it's between e and 1. Now actually I'm probably going to need a lot of room to do this, so I'm going to go onto a fresh page. And here we go. So we got pi times, so e cubed over 3 times 1 squared, so it's just that, minus 2/3 lots of e cubed over 3, again the ln e is just 1, minus e cubed over 9. And of course that's minus, and I'm going to put the pi there, so I've done them separately. So we've got now, substituting in 1, so we've got 1 over 3 times ln 1. ln 1 is 0, so I can actually get rid of that. That's just going to be 0 minus 2/3, and then again we're going to get a 0, just minus 1/9 there. Now, so my first one is actually going to be 5 over 27 pi minus, and don't forget my e there, and that's going to be minus 2 over 27 pi. So I can leave it like this, or I could put it in the form of pi over 27 on the outside and 5e minus 2 on the inside. And sorry, actually I put the e in, but it's e cubed, so I just go back in and put in the cube there. Almost forgot that. And that there is my final answer in its simplest form. Actually seems like a fair amount of work for 7 marks, to be honest, but anyway. So with this one we're looking at the rate of change of the height. So let's start by thinking about what we know. So volume, pi r squared h. We know the radius is 4, so 16 pi h is my volume. And I can also get a dv by dh, which will be 16 pi. That might be useful later. Now, when I think of this rate here, it's meters cubed per minute. Okay, so that's a dv by dt. And we have 0.6 pi flowing in, and we have flowing out 0.15 pi h. 0.15 pi h. So that is my rate of change in volume. I've got flowing in and I've got some flowing out. Now, to make my dh by dt, I can combine these two. So we want dh by dt, So we want h on the top. So dh by dv times dv by dt. And that works because the dv's would cancel, leave me dh by dt. So dh by dv is going to be 1 over 16 pi. And dv by dt we know is 0.6 pi minus 0.15 pi h. Right, let's write it as a nice single fraction here. It's a little bit nicer. Now, in terms of fractions, the 0.15 is 3 over 20 in its simplest form. So I'm going to write the 0.6 over 20. So 0.6 is 6/10, so that's going to be 12 over 20 pi. And then factorising out the top, I'm just going to factorise out 3 over 20. No, actually I'm not, because looking here, there's a 12 and a 3 in there, which is what we've got. So let's just factorise out pi and the 20. That'll leave me 12 minus 3h inside over 16 pi. Now, my pi's can definitely cancel, and you can see that right from the start. And then we're left with this 1 over 20 on the outside. So that now becomes 12 minus 3h. 20 times 16 is 320, and we got what we wanted, so as required. So the depth is 0.5 when the tap opens, so we know that h is 0.5 meters when time equals 0. That's going to help us. And now dh by dt we know is 12 minus 3h over 320. Now let's rearrange. So we get 1 over 12 minus 3h dh on the left, 1 over 320 dt on the right. And then I will integrate. So I can take a factor of 3 out of this one, leaving me 1 over 4 minus h dh, and obviously I could do the same here on that one, I'm not going to bother. So on my left I've got 1/3 ln 4 minus h, and then I'd have to divide by minus 1, so it's going to become a minus. And then we've got t over 320 plus a constant. Then h equals 0.5 when t equals 0, so we've got minus 3 ln 4 minus a half equals 0 plus c. So c equals minus 1/3 ln, and it's 3.5 or 7 over 2. And putting that together, we've got the horrible looking 320 minus 1/3 and then 7 over 2. Now I'm going to take the logs to one side. Shouldn't really matter which way around I do this, but let's just go for it. So 1/3 ln 7 over 2 minus 1/3 ln 4 minus h equals t over 320. And then let's multiply by 3, so we get ln 7 over 2 minus ln 4 minus h equals 3t over 320. Now, luckily I don't have to go much further than this. Actually, I could have used this first line with the thirds in it, but it makes no difference. So we want to substitute in 3.5, so ln 7 over 2 minus ln 4 minus 3.5 equals 3t over 320. And once I've substituted this in and then multiply by 320 and divide by 3, I get that t is 207.56 minutes, or if you wanted it in hours, it would be 3 hours, 27 minutes, and 34 seconds to the nearest second there. Seemed to be a fair bit of work there for 6 marks. Let me know in the comments if you actually found a quicker way. Also let me know in the comments if I have made a silly mistake in this, because I'm doing this and it is quite late in the evening. I mean, tired, see, because I sometimes make silly mistakes. So let me know in the comments if you spot anything. So filling in the missing line means that we just take a factor of 2 out. We have 4p cubed plus 6p squared plus 3p, then plus 1. Okay, I'll write it just underneath, hopefully, just in case it's not as clear. So you're just factoring out that 2 as then quite clearly this is an even number, plus 1 will make it odd. So we need to assume, or our assumption, that cube root of 2 is rational, and therefore can be written in the form of a over b, and there are no common factors between a and b. Now, next step then is to cube both my sides, so I get 2 equals a cubed over b cubed, or 2b cubed equals a cubed. This means that a cubed must be even, and therefore a can be written as 2n. So my a cubed equals 2b cubed now becomes 2n cubed equals 2b cubed, which is 8n cubed equals 2b cubed, or 4n cubed equals b cubed. I can also write this as 2n cubed equals b cubed, therefore b is an even number. And now we're also there, because if both a and b are even, then they have a common factor of 2, and this is going to contradict the statement that a and b have no common factors, and then we can do our conclusion. And that's it done. Hopefully you found some use in today's video, and as I said previously, just let me know if there are any little mistakes. Some of these past paper videos do take a while to record, and sometimes I do get a little bit tired and make the odd calculator mistake. So just let me know in the comments so that I can fix anything if you do notice anything. Thank you for watching. See you soon.